let's see. Where do you think the word base is going to go? What line, or what segment? XZ. Where do you think the legs are going to go? X, Y, and YZ. What do we know about the legs of isosceles triangles? They are congruent, so they're always going to be marked. Okay. Vertex angle, where do you think that's going? 2, very good. And base angles are going to go where? 1 and 3. Alright, so we know that with isosceles triangles that we have 2 congruent sides, and we refer to those as our legs, and then you have your base. Okay, what else do you guys know about isosceles triangles? So other than that they have 2 sides congruent, what else do they have congruent? Radica? They're base angles, and Maddie said it too. Your base angles are also congruent. So if X, Y, and YZ are congruent, then angle 1 and angle 3 will also be congruent. And that brings us to our first little fill in the blank. Base angles theorem. This should say base, it got hole punched out. Okay, and it states that if 2 sides of a triangle are congruent, then the angles opposite, these sides are congruent. So all it's saying is that if you have 2 sides that are congruent, okay, then you have an isosceles triangle for 1, and then that the opposite angles are also congruent. So angle X opens up to side YZ. So notice how angle 1 opens up to YZ, and angle 3 opens up to YX. Okay, and those angles are congruent. Okay, so just like we had when we talked about transversals and parallel lines, we had alternate interior angles theorem, and we had the converse of that to prove lines that were parallel. Okay, now we have base angles theorem and converse of base angles theorem. So what do you think the converse of what we just wrote would be? Very good. So remember that when we write a conditional statement, it's if P, then Q. So the converse is if Q, then P. So you're just switching it. And that's going to state that if 2 angles of a triangle are congruent, then the two sides opposite these angles are congruent. Okay, real quick to see if we are understanding. Okay, it's angle 2, so we're going to use this diagram. Okay, so XY is congruent to YZ. If angle 2 is 100 degrees, what would angle 1 be? 40. Why is it 40? Very good. X and Z are both the same, so they both could be X. Okay, and if angle 2 is 100, 180 minus 100 is 80 degrees. So 80 degrees has to be within angles 1 and 3, which means that each one has to be 40 because they are the same. Okay, if I... Yeah. Sorry, I wasn't here when you explained why they're congruent. It's a properties of isosceles triangles. So as long as you have 2 congruent sides, the opposite angles are also congruent. if I had, let's say, 80 degrees here, 50 degrees here, 50 degrees here, and this leg was 10 centimeters, and I asked you for the length of YZ, what would it be? 10 centimeters. As long as your base angles are the same, you know that your two legs have got to be congruent. Okay, so that's just the basic gist of properties of isosceles triangles. Okay, so now we're going to apply that, number 1 and 2. Okay, let's start with this triangle here. Okay, if our vertex angle is 60 degrees, how many degrees are within these two angles? 120, which would mean that both angles are what? 60 degrees. Okay, this just so happens to be what kind of triangle? An equilateral, but they labeled it only as an isosceles, but it would be an equilateral. You would be able to make that conclusion after solving for the other angles. Okay, so now let's look at this triangle over here. If these two sides are what are congruent, okay, those are our legs, what would this angle be? 120. This angle. Oh, that was 30. 30, okay, because they are the angles that are opposite of your congruent sides. Okay, so if that's 30 and that's 30, that's 60, so A would have to be what? 120. 120. What would be another way of solving for angle A? Subtracting 60 from 180, because these two angles are what? Not vertical angles. Supplementary angles. Very good. Alright, try number 2 on your own. Take about 30 more seconds. Alright, what is X? 50 degrees, and how did you find out that that was 50 degrees? Very good. So you know the sum of your interior angles of a triangle is always going to be equal to 180. So you can just take 180 and subtract the 2 that you're given, and you'll end up with 50. So now that tells you we have an isosceles triangle, right, with these two sides congruent, because they're the sides that are opposite of our congruent base angles. So then you had 40 equals 8y. And so what did you guys get for y? Very good. Okay, so that is pretty much all there is to isosceles triangles. Obviously, you can make the problems harder, and we'll see that in a second. But are there any questions with just the basics before we move on? We're good? Okay. So, of course, we have proofs, number 3 and 4. 3 specifically is just review from last class. This doesn't really have anything to do with isosceles triangles. Okay, 4 we'll get into isosceles a little bit, and then I'm going to give you one more proof on the back of these notes, but later on. First thing, statements and reasons. So, again, this is just review. This is not isosceles, but I would make sure I know how to do it. Okay, your first statement is always your given. So CW and SD bisect each other. When things bisect each other, it is completely different than them just intersecting each other. Okay, so make sure you know the difference. Okay, your second step usually will go along with something that your first step or your given said. Okay, so when CW and SD bisect each other, what happens? What's congruent? C to P and C to P and PW are also congruent, but what else is congruent? SP and PD, because it is bisected each other. Okay, it wasn't CW bisects SD. Okay, it was CW and SD bisect each other. Okay, so they split each other in half. So we have CP is congruent to WP, and SP is congruent to DP. And what would our reason be? Definition of segment bisector. Okay, what else do we have? Vertical angles, and how do we name those? Very good. CPS is congruent to WPD, and why would that be? Oh, yeah, you already said it. Vertical angles. Okay, do we have three things in each triangle congruent? Yes, so that means we can write a what? Congruency statement. So what would our congruency statement be? Very good. What would be our reason? Side angle side. So you have side angle side. Side angle side. Yes. You could have. So you could have skipped this vertical angle step and done HL. Okay, now what can we say? Very good, and why is that? Yeah, C, P, C, T, C. So remember, every other letter is a C, and then P, T, and I think of like physical therapy or part-time. Whatever helps you, or maybe it doesn't help you at all. Okay, so that's a review. Like Ashita said, you could have done hypotenuse leg as well. There was multiple approaches to that problem. Alright, number 4, create a proof of the following. I also want to add in here GU bisects angle BGD. GB is congruent to GD, and GU bisects angle BGD. Okay, and we're trying to prove that B and D are congruent. If I told you that you could do this in 2 steps, how would you do it? Radhika? Base angles theorem, right? So since you have 2 congruent sides that are opposite of 2 angles, you have an isosceles triangle, correct? And then you would have your base angles theorem. Okay, so that's one way you could have proved it in just 2 short steps. However, I want to also look at another way to prove it. Okay, so somebody give me something else. Ashita? GU equals GU. And why is that? Reflexive. What else do we have? Holly?
Angle DGU equals angle UGB.
Very good. Angle DGU is congruent to angle BGU, and why is that?
The definition of angle bisector.
Definition of angle bisector. Okay, how many things so far do I have congruent? 3, so what should I be able to do now? A congruency statement. Somebody give me one.
DGU is congruent to triangle BGU.
Sorry. Oh my goodness. It's just my copies already. That's it. Okay. And that was because of what? Side angle side.
And you got the outside side thing because of
This?
yeah.
Because that's what it gave us.
Okay.
Okay, and then step 5 would be what? B is congruent to D because of C, P, C, T, C. Very good. Any questions on those two proofs? No? Okay, before we move on, go ahead and flip to the back. We're going to do one more proof. Alright. Here we go. This is proof number 3. You're given CA is congruent. I'll draw you a picture too. AT and TO is congruent to DO. And we're proving that angle 3 is congruent to angle 6.
Is it TO?
Yeah. There's my beautiful picture.
Does it say DO? Yeah. That's it.
Oh, my picture's bad. This should be 6. I'll make it a little bit prettier. That's angle 6. Alright, so I'm going to mark what I have so far. CA is congruent to AT, which is congruent to TO and DO. These should have doubles, sorry.
Are we doing this or not?
No. Statement. Reasons. Okay, our first ones are given. Alright, so looking at one triangle at a time, let's look at triangle CAT. What do we know? What kind of triangle is it? An isosceles triangle. Okay, so what else do we know? Angle 3 is congruent to angle 4. Why is that? Base angles theorem. What else what other statement could we have for that same reason? Angle 5 is congruent to angle 6. So we know that 3 is equal to 4, 5 is equal to 6. Radhika. Very good. 4 is congruent to 5 because of vertical angles. Okay, our end goal is to prove that 3 is congruent to 6. Radhika? Okay, can't go straight there yet, but you're on the right track. Amanya?
Angle 3 and 5 are equal because of substitution.
Very good. 3 and 5 are congruent because of substitution. Now, Radhika, what can you say?
Angle 2 and 6 because of substitution.
Very good. And you're done. So if 3 was congruent to 4, and 4 is congruent to 5, then you know that 3 and 5 have to also be congruent. Okay, now you have 3 is congruent to 5, and you know that 5 is also congruent to 6, so I can substitute in 6 for 5, and that's how we end up at 3 is congruent to 6.
Which formula do you know to make them memorize or something like that?
I mean, being that I took time to do this off to the side, I'd make sure I know that one. But there's a total of 2. This one and then the ones that are on your review are a pretty good indicator of something that you'll see. So yeah, I wouldn't just like throw this away or disregard it. Okay, I know that there's questions because I see a lot of frazzled faces, so ask away before we move on.
Where does base angle theory come in?
The front. Any other questions on this proof? No?
Oh.
Yeah.
How do you know when to put the
CPCTC is after you've proven that triangles are congruent. What does it stand for? Corresponding parts of congruent triangles are congruent.
Could you prove the triangle's congruent and then say 3 and 6 are because of CPCTC?
I'm trying to think of how you would get there. Because if you don't use... You would have to get still all the way down to here, then prove the triangles are congruent.
Okay.
Because if you just have that 3 is congruent to 4 and 5 is congruent to 6, you still don't know at that point that these are congruent to each other. You only know that 4 is congruent to 5, and then you have ASS, and that's never a... You would have angle side side. So you still would have to somehow get to 3 is congruent to 6. Does that make sense?
Yeah.
Okay. Any other questions?
So would this be like that angle?
This would not be any of that. Okay. Turn back to where we were then, number 5. We're going to review your quiz, Bella, on like that whole back part, so that might clear up the questions on those things. Alright. Number 5, calculate AP if the perimeter of AYP is 43 centimeters. So, what two sides are congruent? AY and AP, because here's your congruent angles. Okay, so this would be the converse base angles theorem, because if you have two congruent base angles, then the opposite sides have to be congruent. So if I were to label these each as x, how would I figure out what AP is? 43 is going to equal 13 plus x plus x. If I combine like terms, I have 13 plus 2x, and you would just solve. It's given.
Can you just do 43 minus 13 divided by 2?
Yeah, that's what you're doing. Because you'll end up subtracting 13, and you'll get 20. I lied, 30. And then dividing it by 2. So x is going to equal what? 15, and of course x was AP, so AP equals 15 what? Centimeters. 30. Any questions on that one? You'll see that one again. Are we hanging in there? So far, so good.
You just put the total equals like
The sum of all three sides, because it's perimeter. And you know that since it's an isosceles triangle, two sides are the same. Alright, number 6, calculate the measure of angle T. Okay, again we have an isosceles triangle, which means what?
the base angles are the same.
Base angles are the same, so these could both be x. How could we figure out the measure of angle x?
180 minus 117.
180 minus 117, because angle x and 117 degrees are supplementary. So you have 180 minus 117, and what do you get for as the measure of angle T? 63 degrees. Oh, I lied. 63 degrees is what angle?
M and W.
M and W. Sorry. Okay, so if these are both 63 degrees, and it asks for angle T, how would you go about solving for T, Maddie? 180 minus 63 minus 63. And what do you get for T? 54. So again, on that one, if you don't know supplementary angles, you'll be real lost. Okay, so it's bringing back those old vocab words. Any questions? Okay. Number 7, given triangle MHR, MH is 20 centimeters, MR is 2x plus y, HR equals 3x minus w. Find x. If necessary, round your answer to the nearest thousandth. What kind of triangle do we have? An equilateral, because all three angles are the same. So I need to solve here. I have x and a y, so you know you're going to be solving a system, whether it's substitution or elimination. Okay, is up to you. Okay, so what could one equation be? 20 equals 2x plus y, and what's another equation? 20 equals 3x minus y. Okay, so these are my two equations that I'm working with. Okay, you can solve for y in one of these and substitute in. You could solve for x and substitute in. You could use elimination by eliminating your y's and adding your two equations. It is up to you, but take a minute and solve for x and solve for y. After you finish 7, go ahead and try the rest of them as we wait for everybody else. You have to. Anytime you have two variables, you need more than one equation. Once you finish 7, go on and try the rest of them. Give you 2 more minutes. Bless you. So these problems are really a true test of your algebra. It's not necessarily geometry, other than knowing the properties of isosceles triangles, but you've got to be able to do your algebra in your system. Alright, for number 7, what did we get for x?
8.
8, and y?
4.
4. Anybody get something different?
Can you work it out?
Yeah.
But I didn't know where to find one.
So, you only had to find x, so if you only did x, that's fine. Okay, I would do this problem by elimination just because you already have a positive y and a negative y, and if I add these two equations together, those cancel. And so then you'll have 20 plus 20 is 40, 2x plus 3x is 5x, and you solve. And you get 8 equals x. However, I'm sure most of you guys did substitution. And I'm guessing you maybe solved for y. So you got y equals 20 minus 2x. And then substitute it in. So you would have 20 equals 3x minus 20 minus 2x. So you have 20 equals 3x minus 20. A double negative here is a positive, so plus 2x. And then you're left with the same thing. 20 equals 5x minus 20. Add 20 to both sides. 40 equals 5x. So 8 equals x, and then you would just go back and substitute in for y. So this is substitution method. This was elimination method. Any questions on number 7? Okay, so that's strictly algebra. Okay, solving systems.
Wait, then you plug in x for
So I can plug in 8 for either one of these x's. Okay, number 8. What do we get for y? What do we get for y for number 8? 16. Any questions on that one? Okay, you know that this is 65 degrees as well. 65 plus 65 is 130. So that means that there's a 50-degree angle right here in order for the sum of those interior angles to be 180. So you just set up an equation, 3y plus 2 equals 50, and solve. So any questions on that one? Okay, number 9. How'd you guys solve for y? Very good. So when you solve that equation, what'd you get for y? 11. Okay, so you know this is 72 degrees as well. So what does this angle have to equal? 36. So now you have 9x equals 36. So what does x equal? 4. Very good.
Wait, I thought you do angles like across the line. Like the x, that's the other line.
These two angles are congruent, which means these two sides are congruent. Okay, there's a lot of chitter chatter. Let's stop. Let's finish the last problem, and then you will be free. Well, actually, you won't be free because we're going to go over your quiz. Okay, how'd you solve for y in number 10? 5y minus 1 is equal to 2y plus 11. So when you solved, what'd you get for y? 4. Ooh, x is a good one. How did you solve for x? Okay, so like Holly said, you're going to add up all your interior angles and set it equal to 180. What does this angle equal? 2x plus 5. Very good. So you have 3x minus 5 plus 2x plus 5 plus 2x plus 5. And you had to combine all those like terms and solve. Your last step should have been 7x plus 5 equals 180. And what did you end up with x for x? 25. Very good. Okay, so that's as hard as the isosceles problems get. Okay, I think the proof's probably the hardest part just because, again, it's introducing a new term. But are there any questions before we put this away for a little bit and go over your quiz? No? Alright, Joseph, are you ready to take a skills check or what?
No.
No? Okay, get outside. Luke, go outside. No, I'm talking about the one that he missed, which he should be able to take.